9.5, nonlinear systems of equations. So previously we talked about solving linear systems of equations, either with 2 or 3 equations, and with 2 or 3 variables. So now we're going to talk about solving nonlinear systems of equations, which just means that at least one of the equations in our system is not a line. Well, to solve nonlinear systems of equations, we can use the same methods that we did previously, either substitution or elimination, or a combination of methods. So let's take an example of each. X squared plus y is equal to 6, and x minus y is equal to negative 4. So I'm going to solve this one by substitution. I see that I can easily find x, and I can say x is equal to y minus 4. So I can plug that into my first equation here. I have y minus 4 squared plus y is equal to 6. Y minus 4 squared, that's the square of a difference. So that's y squared minus 8y plus 16 plus y is equal to 6. Y squared minus 7y plus 10 is equal to 0. So now that I have that, I can solve for y. And notice that I can factor so I can find y, right? We need two numbers that multiply to 10 and add to negative 7. That would be negative 2 and negative 5. So y minus 2 times y minus 5 is equal to 0. So y is equal to 2, or y is equal to 5. So then I have y equal to 2 and y equal to 5. I can plug that into one of my original equations and find x. So I'm going to choose to plug into the second one just because that seems a little bit easier. So x minus 2 is equal to negative 4, or x is equal to negative 2. Add 2 to both sides. And x minus 5 is equal to negative 4. Add 5 to both sides, and x is equal to 1. So when y was equal to 2, x is equal to negative 2, so we have negative 2, 2. And when y was equal to 5, x was equal to 1. So we have 1, 5. And we have our two solutions to this nonlinear system of equations. Now, one thing that I should point out here is when we were dealing with linear systems or systems of linear equations, you either had one solution, or you had no solutions, or you had an infinite number of solutions, because everything you were dealing with was a line. So they either intersected, they were the same line, or they were parallel, so they never touched. Whereas now, since we're dealing with nonlinear, they can touch more than once. X squared plus y equal to 6, that's a parabola. So a line may either have no solutions, or I should say if a line may pass through it never, a line may pass through it once if it just touches it at one point, or a line may pass through it twice. So you can have no solutions, one solution, or two solutions. And in this case, we had two solutions. It passes through at negative 2, 2 and 1, 5. So that was using substitution. Let's do another example using elimination. X squared plus y squared is equal to 9. 9x squared plus 4y squared is equal to 36. So if I'm going to use elimination, I'm going to multiply this top one by 4. So I get 4x squared plus 4y squared plus 36. Since these are both have the same coefficient, I'm going to subtract. 9x squared minus 4x squared gives you 5x squared. 4y squared minus 4y squared gives you 0y squared. That was supposed to be an equals. And 36 minus 36 is 0. So divide both sides by 5, x squared is equal to 0. So x is equal to plus or minus 0, which obviously is just plain 0. X equal to 0. So now that I have x equal to 0, I can plug that into the original equation. So I have 0 plus y squared is equal to 9, y squared is equal to 9, or y is equal to plus or minus 3. So we have 0, negative 3, and 0, positive 3. Again, two solutions. So there we go. In this particular case, we actually have, to me it looks like a circle and an ellipse, which means they could cross in a number of ways. You could have them never touch, you could have them touch in one spot, you could have them touch in 2 spots, they could touch potentially in 3 spots or 4 spots. It just depends on how they're shaped. They could even end up touching in more spots than that, depending on the shape of the ellipse in a circle. So here we go. So we had 2 solutions to this one. Now let's look at one where we have to kind of combine methods a bit and really play with it. X squared plus xy plus y squared is equal to 21. X squared minus xy plus y squared is equal to 9. So I've got x squareds, I've got y squareds, I've got xy. So you do see an obvious xy and negative xy. You can cancel those out, and then you'd end up with these x squareds and y squareds equal to that. So that is a possibility, but what I like better is I can cancel out x squareds and y squareds in the same shot, just leaving me with xy. So that's what I'm going to do. So I'm going to subtract instead of adding. X squared minus x squared gives me 0. Xy minus negative xy gives me 2xy. Y squared minus y squared gives me 0. 21 minus 9 gives me 12. Divide both sides by 2, and you get xy is equal to 6. And now I can solve this for either x or y. So I'm going to solve it for x. So I'm going to say x is equal to 6 over y. So that's good. So that gives me a start. Now what do I want to do? Well, I'm going to substitute that back into one of these equations, and I'm going to choose this bottom one. So I'm going to say 6 over y squared minus 6 over y times y plus y squared is equal to 9. Now you may ask me, why did I choose the bottom one? Well, no real reason except for 9 is smaller than 21. Otherwise, they're pretty much equivalent equations. So, and remember, these are y's, not 4's. Sorry, my y's and 4's tend to look somewhat similar. So that gives me 36 over y squared, using some of our power rules, minus, well, 6 over y times y, the y's cancel out, so minus 6 plus y squared is equal to 9. Well, I don't want this y squared in the denominator, so I'm going to multiply through by y squared. Gives me 36 minus 6y squared plus y to the 4th is equal to 9y squared. So arranging it and combining like terms, I have y to the 4th minus 15y squared plus 36 is equal to 0. Now what I notice here is, first of all, I probably would have been better off putting it further off to the side so I'd had more space to work. But secondly, I notice that I've got y to the 4th, y squared, y to the 0, which means I can substitute and I say let u equal y squared. So now I have u squared minus 15u plus 36 is equal to 0. And if I do that, I see that I can look at this and say two numbers that multiply to 36 and add to negative 15, negative 12 and negative 3. So u minus 12, u minus 3 is equal to 0. You can just barely see that on the screen. So therefore, I can say that u is equal to 3 and 12. So I've got those two u's. Well, u's equal to what? Y squared. So y squared is equal to 3, and y squared is equal to 12. So y is equal to plus or minus the square root of 3, and y is equal to plus or minus the square root of 12. Well, the square root of 12 is 2 square root of 3. So I can say, and I'm going to move this out of the way, just give myself a little more working space. There we go. Is equal to plus or minus 2 radical 3. So I've got y equal to plus or minus the radical 3, and y equals plus or minus 2 radical 3. Now, I can plug those into prior equations to get answers, or find out what x is. So, I'm going to kind of cheat a little bit. I'm going to come here. I say it's cheating a little bit because it's a really simple, or I should say I'm going to come here. It's a really simple equation, but I got to it by canceling out. So I could go in, I could plug these into one of these original equations, but it looks like a lot more work to me. So I'm just going to use x equal to 6 over y. So if I let y equal to the square root of 3, then x is equal to 6 over the square root of 3, which is equal to 6 square root of 3 over 3, which is equal to 2 square root of 3. If y is equal to negative square root of 3, then x is equal to 6 over negative square root of 3, which is equal to negative 2 square root of 3. If y is equal to 2 square root of 3, then x is equal to 6 over 2 square root of 3, which is equal to 3 over square root of 3, which is equal to 3 square root of 3 over 3, or the square root of 3. And if y is equal to negative 2 square root of 3, then x is equal to 6 over negative 2 square root of 3 is equal to negative square root of 3. Whew. So, starting from the top, x2 square root of 3, y square root of 3, negative 2 square root of 3, negative square root of 3, square root of 3, 2 square root of 3, and negative square root of 3, negative 2 square root of 3. So we find 4 solutions to this set of nonlinear equations. So as I said, we can run into a number of different solutions. Linear was actually much easier because we knew none, 1, or an infinite number. When you start dealing with nonlinear equations, you don't know what's going to happen. You can end up with a lot of them, you can end up with little, and you can end up with none of them. So it all depends on the equations we're dealing with. Okay, so that was fun. So let's try another type. Where we're going to deal with an absolute value. So let's say we've got x squared plus y squared is equal to 4, and negative absolute value of x plus y is equal to 0. Well, nothing says we have to use any specific method, whatever works best. I see this y sitting here and this absolute value sitting there, and I'm going, boy, that even seems like that should be pretty easy. Why don't I make y equal to the absolute value of x? Okay, so if y is equal to the absolute value of x, I can plug that in here, so I get x squared plus the absolute value of x squared is equal to 4. I don't know why I keep wanting to put a plus when I want equals. It's equal to 4. Well, if you're taking the absolute value of x and squaring it, that doesn't really do anything. So we have x squared plus x squared is equal to 4, or 2x squared is equal to 4. Divide both sides by 2, x squared is equal to 2. So x is equal to plus or minus the square root of 2. Okay, simple enough. So then let's plug this into one of these equations. And why not use the bottom one here, this absolute value? So if I take negative absolute value of the square root of 2, oops, that's supposed to be an absolute value, not a parenthesis, plus y is equal to 0, then the absolute value of the square root of 2 is the square root of 2, negative square root of 2, so I get negative square root of 2 is equal to, plus y is equal to 0, so y is equal to the square root of 2. So what happens if x is equal to negative square root of 2? So we have negative absolute value of negative square root of 2 plus y is equal to 0. The absolute value of the square root of 2, of the negative square root of 2 is is square root of 2. The negation of that is negative square root of 2 plus y is equal to 0. Y is equal to the square root of 2. So we have two solutions. Square root of 2, square root of 2, and negative square root of 2, square root of 2. So two solutions dealing with the absolute value. So it's all the same processes. It's not like we're getting into anything fancy or different. It's just the same thing, just with different problems, different little things that we're looking at, square roots or absolute values, or squaring things, or mixing variables. Doesn't change much of anything. We just have to think a little bit as we go through it. So now I'm going to look at another problem. And this one's going to get just a little more interesting. So let's say I have x squared plus y squared is equal to 6. And 3x squared plus 2y squared is equal to 8. So I have these two, and I can cancel. I could multiply this top by 2 or 3, so I could cancel out through elimination, or I can substitute. I'm going to choose to substitute in this one. Why? Just because I can. And why not? Right? So I can say x squared is equal to negative y squared plus 6. And if I do that, I can plug that x squared in here. So I can say 3 times negative y squared plus 6. And notice that I'm not substituting for x, I'm substituting for x squared. So x squared gets substituted as negative y squared plus 6. I don't have to square that afterwards. Plus 2y squared is equal to 8. Distribute through, negative 3y squared plus 18 plus 2y squared equal to 8. Negative 3y squared plus 2y squared gives us negative y squared. Subtract 18 from both sides, you get negative 10. So y squared is equal to positive 10, or y is equal to plus or minus the square root of 10. So now I have my y values. So I can plug this into here and get my x values. In fact, I could even take it here and plug it in. Let's see what happens. I'm going to take this though because it's going to show me what really happens. With this, you kind of ignore the fact that there's a plus and minus. But I do realize that either one of these squared will go in, so I can plug it in there. I just have to realize that either one of these will give me a result for that. So if I'm looking at that, I can say that $10 plus y squared, do it the other way. Y squared is equal to 10, so x squared plus 10 is equal to 6. So x squared is equal to negative 4. X is equal to plus or minus the square root of negative 4. Well, the square root of negative 4, that's an imaginary number, so x is equal to plus or minus 2i. And y is equal to plus or minus the square root of 10. So basically, what I'm looking at here is there's 4 possibilities. So I can say x is 2i, and y is the positive square root of 10. Oops, not a 2, a 10. X is negative 2i, and y is the square root of 10. And I can say x is 2i, and y is negative square root of 10. And x is negative 2i, and y is the negative square root of 10. So 4 possibilities: 2i square root of 10, negative 2i square root of 10. 2i negative square root of 10, negative 2i negative square root of 10. So we have to look at all of the possible solutions, and then we can of course plug all these in there. It should make sense that x and y, you're going to have the plus and minus on them because we have x squared and y squared in both of these. So a negative value of x acts the same as a positive value because it's going to get squared. A negative value of y acts the same as a positive value of y because it's going to get squared. So it shouldn't be a shock that we end up with these 4 solutions. And yes, those solutions include imaginary numbers. So that is a possibility. Just because we like to deal with real numbers doesn't mean that everything turns out to be real numbers. And that finishes up 9.5 nonlinear systems of equations.